Okay, everybody, this is the video explaining the three trying your own examples. Hopefully you had a chance to give them a shot. I'm going to explain sort of the solutions and the ways to get around these, okay? So for the try on your own number one, we have a problem that's very similar to the first example, which is the integral of x cosine x. And so we see there that I've got a multiplication of two different types of functions, an algebraic function in x to the first, and then trigonometric function in cosine of x. So that's a good telltale sign that I'm probably going to use integration by parts. It's worth noting that just because it's multiplication doesn't mean you have to use integration by parts. There's plenty of integrals that involve multiplication that might use a u substitution or some other type of technique that we'll learn. But when you see that multiplication, integration by parts should definitely be something you're thinking about using because it does work a fair amount of times. Okay, so again, remember, what are we trying to do here? We need to break this into parts. We're going to make one equal to u and one equal to dv. We'll differentiate one, and then we'll integrate the other. Remembering our acronym that we learned, which is LIATE, L-I-A-T-E, which stood for the type of functions that you're working with. Whatever one of those is involved in the problem comes first in that acronym, that's the one you want to make u equal to that you'll differentiate. Those are the ones that are easier to differentiate and that simplify themselves. So looking at this, hopefully we saw that since x is an algebraic function, and it's really simple because the derivative of x just goes to 1 dx. That's what we made u equal to. Therefore, we have to make cosine equal to dv. If we take the integral of that, we get sine of x. Okay, so now I've got all my four parts, and I'll put it into my integration by parts formula, and I'm just going to kind of show the rest here. So u times v, which is x times sine x, minus the integral of v du. This simplifies really nicely because it just becomes the integral of sine dx, which I know is negative cosine. Okay, and sorry about that. So the integral of sine is negative cosine, which turns it to a plus cosine of x, right? So x sine of x plus cosine of x plus c is your answer. All right, let's go to number two. So we've got the integral of 3x to the fourth multiplied by the natural log of x. And again, thinking about my acronym, as soon as I see that logarithmic function, the natural log, almost every single time you're going to make that equal to u, and whatever's left over is going to be dv. Okay, so if I check out my first step, I'll make u equal to natural log of x. Its derivative becomes 1 over x. dv will be 3x to the fourth, so I'll just use the power rule for integration there. So the integral of 3x to the fourth is 3/5 x to the fifth. I've got my four parts, and I'm going to put it into my by parts formula. So u times v in the front there, 3/5 x to the fifth multiplied by natural log of x minus the integral of v, 3/5 x to the fifth, du, which is 1 over x dx. Okay, and we'll see that x to the fifth multiplied by 1 over x is really x to the fifth divided by x, which is just going to be x to the fourth. So my next step, I'll pull out the 3/5 constant in front of the integral, and then I've simplified the x to the fifth over x to the fourth, making that integral also very easy because, again, it's just another power rule. So my final answer, 3/5 x to the fifth natural log of x, that's still that original u times v, minus 3/25 x to the fifth plus c, right? And that 3/25 comes from the integral of x to the fourth is x to the fifth over 5. So I still have that 3/5 out in front. So I'll just multiply those two denominators to get 25 as a denominator. And so that's where we could stop. That's a final answer. If we wanted to simplify it a little bit further, I noticed that both parts here, I'll just circle them here so you can see it. So this part and this part do have a common term, which is 3/5 x to the fifth. And so you can factor that out, and this would be your most simplified version in that second orange box. Okay. All right, last one, and I admit this was definitely one of the more challenging ones because you had to do a couple of different steps here. But this one's really similar to when we found the integral of the natural log of x. And that's because we notice there's no multiplication. There's really only one type of function involved, which is that inverse trigonometric function. Excuse me. And so that's really our only option to make u equal to. And again, if we're thinking about our acronym, LIATE, L-I, I is inverse trig. So more than likely, I would naturally make u equal to inverse sine of x anyway. But what we have to remember is that we do still have that dx piece, which is involved. It is multiplied by the inverse sign. So I can make that one of my parts of the problem. All right, so I'll make u equal to inverse sine of x du. I'm going to take the derivative of inverse sine, which is 1 over the square root of 1 minus x squared. dv equals dx. If I integrate dx, remember, which is really just 1 dx, I get v is equal to x to the first itself. Okay. So while it might seem like we're complicating this a little bit because 1 over the square root of 1 minus x squared isn't sort of the most simplistic function to work with, this actually works out really, really nicely for us. Let's put it all together. All right. So using the by parts formula, put it right here, I see that the integral of inverse sine is equal to u times v, right? So x inverse sine of x minus the integral of v du. So I'll multiply x by 1 over the square root of 1 minus x squared. And so I've got this integral now to work with. If I had to just maybe pause for a second, how would we go about finding this integral now? So it's not really as straightforward as the last two examples, but you do know how to do this prior to this course. I'll give you a second just to think about it. So hopefully you thought about your other techniques that you know, and specifically the most powerful one, which is integration by substitution or u substitution. I note that the inside of the radical on the denominator, 1 minus x squared, if I take its derivative, I get negative 2x, which is a form of the numerator, right? So 2x to the first, I have an x to the first in the numerator, so I can use u substitution really nicely here. So my next step here is I'm going to just sort of use some notation here so it's not confusing with the u I used in the beginning of the problem. So I'll say u sub 1 for my u substitution on this part is equal to 1 minus x squared. I know I need to take its derivative, which is negative 2x, which we just said. And so in order to match up the two integrals exactly, I'll divide by negative 2 on both sides. And so I know that du sub 1 divided by negative 2 is equal to x dx, right? And that's that substitution I'll make. So I'll make u sub 1 equal to 1 minus x squared, and x dx equal to du sub 1 over negative 2. So finish this one out, one more slide. Putting that all together, so this is what we just said, right? So putting that all together, here's my u substitution. That is going to filter into that integral becoming really just negative 1/2, right? That du sub 1 over negative 2 is equal to negative 1/2 the integral of 1 over the square root of u. Should say u sub 1, but this is just inside of this one u substitution. And so now I know I can do the integral of 1 over the square root of u pretty easily. It is just another power rule, right? It's really u to the negative 1/2. And so that's going to equal negative 1/2 multiplied by 2 times the square root of u plus c. Negative 1/2 times 2 is just negative 1. So I really get negative the square root of u plus c. But again, remember, that's just that one piece of the integral, right, from the original problem. So this, right, really just filters into here. Okay, so that's that integral, but I still have the other part left. So I'm just going to have to put that full answer together. Okay, so I'll unveil it here. And so in the end, the integral of the inverse sine of x is equal to x inverse sine of x minus the integral of x divided by 1 minus x squared, square rooted. And so I did just find that integral. And since u sub 1 was equal to 1 minus x squared, I'll replace that piece. And so finally, x inverse sine of x plus the square root of 1 minus x squared, all plus c. And that's it. So again, your homework is posted on My Malvern. Please take a picture of your work and use the My Malvern submission. Make sure the photo is clear. Make sure your handwriting is clear. And let me know if you have any questions. All right. Thanks, guys.